Hello, good morning, and welcome to Magic Academy. Electrolysis. We are moving straight to the point. Electrolysis. Electrolysis can be defined as the decomposition of a compound by passing a direct current, either through the solution of that salt or in its molten form. That is what we call electrolysis. There are other terms we use in electrolysis, such as cathode, anode, electrolytic cell, electrolyte, and so on and so forth. Cathode is simply the negative electrode in an electrolytic cell. The negative electrode in an electrolytic cell. While the anode is the positive electrode in an electrolytic cell. Now, if you're talking about electrolyte, don't forget the definition I gave you of electrolysis. It's just how to decompose a compound by passing a direct current to either the solution of that compound or the molten state. That is just what electrolysis is talking about. So if we are talking about electrolytes are substances which conduct electricity and it's decomposed in the process. While electrolytic cell is the assembly of two electrodes in an electrolytic cell which is used for the electrolysis of a substance. All these things we will dive in details. Remember, I made mention of electrolytic cell. It is where that two electrode will be. Assuming we want to conduct an electrolysis with this salt, this is copper 2 tetraoxide 6. If you want to decompose this compound, if you know chemistry very well, you know that compound, anything that is a compound cannot be separated easily because they are chemically combined together. So if I want to dissociate this compound or the individual element, there's no way you can do it except by electrolyzing the salt solution. If you put this in water, now you pass electricity, you will see that copper, just like this, copper will be dissociated from this SO4, which is negative. So, and of which you know that I said that the cathode is the negative electrode. The negative electrode. While the anode is the positive electrode. So from what I have written now, I just want us to explain it very well. From what I have written now, do you think that when you pass a direct current into the source of this compound and it is dissociated as follows? This one, remember, this is a positively charged, this is negatively charged. Do you think that which one will go to the cathode and which one will go to the anode? Of which copper will come to the cathode and this one, tetrodosi 6 ion, will come to the anode. Because positive will always go to negative. Negative will always go to what? Positive. This is just an example of electricity. Don't forget that when you put this thing into water, it will form as an electrolyte. It will form as an electrolyte. So that is what we mean by electrolytic cell. And that setup, simply let me do a rough sketch. And that setup is simply what we call electrolytic cell. This is copper 2 tetraoxide 6 solution. And let me just say this is the anode, which is positive, and this is the cathode, which is negative. So this is the current. So this is just how it is, which means this copper will be deposited at the cathode, while tetraoxide ion will be deposited at the anode. This is just an example of electrolytic cell. Just an example of electrolytic cell. Now let us see what is electrochemical cell. Electrochemical cell. If you're talking about electrochemical cell, we are talking about that device in which chemical energy is converted to electrical energy. Chemical energy being converted to electrical energy. That is what we call galvanic cell, or that is what we call electrochemical cell. Don't forget, both of them are seems opposite of each other. Here, we decompose a compound to generate we use electricity to decompose a compound in electrolysis. But in electrochemical cell, we use the chemical component of cells to generate electricity. And of which you know, from what I have just said, your torchlight battery is an electrochemical cell because we use the chemical composition of that torchlight battery to generate electricity. So that is what we call electrochemical cell. But it has some differences with electrolytic cell. Remember, if I'm talking about electrolytic cell, I'm talking about electrolysis. Do you get it? So a little difference, or the difference between electrolytic cell and electrochemical cell is this. I told you that cathode is the negative electrode in electrolytic cell, and the anode is the positive electrode. It is not the same in electrolytic cell. Sorry, it's not the same in electrochemical cell. In electrochemical cell, the anode is the negative electrode, while the cathode is the positive electrode. Have you seen a little shift? Don't allow it to confuse you. Anode, negative, cathode, positive, electrochemical. Electrolytic, anode, negative, cathode, positive. Let's take it again. In electrolytic cell, cathode is negative electrode, while anode is positive electrode. While in electrochemical cell, is opposite of the first one I have just said. The cathode becomes positive, while anode becomes what? Negative. That is one of the differences between electrochemical and the electrolytic. Another difference between them is that in electrolytic cell, there is nothing like short bridge or porous partition. While in electrochemical cell, you have short bridge or porous partition. In fact, that is what makes, let me give you the function of that short bridge, if you are comprehending. Let me give you an example of that, the use of that short bridge. Short bridge complete the circuit in electrochemical. It completes the circuit. Two, it maintains electrical neutrality in the two half cells. Remember, if you are talking about whether electrolysis or electrolytic cell, you refer back to what we did in our previous videos about oxidation and reduction reactions. So it permits the mixing of ions in both half cells, but it is selectively permeable. Not every ion will go into the other half cell. So that is function of a short bridge. Now, similarity between electrolytic and electrochemical. In both, electrons will always flow from will always flow from anode to cathode. The electron flow will always go from anode to cathode, no matter the sign, whether positive or negative. Electrons will always move or flow from anode to cathode. Another one, oxidation always occurs at the anode. In oxidation, we have electron loss. So oxidation will always occur at the anode, while reduction occur at the cathode, whether in electrolytic or electrochemical. That is their similarities. So we will be diving into something else.